Hi, this is Alex from devstories.eu. Shapely, Episode 3 of 8. Regular distance tells you the closest two lines get to each other, but if you want to know the absolute furthest they drift apart, regular distance is completely useless. To answer that, you need to understand measurement and properties. Every geometry object in Shapely comes with built-in attributes that describe its physical dimensions. The most basic ones are area, length, and bounds. The area property gives you the two-dimensional space covered by a shape. For a polygon, this is a positive number. For points and lines, the area is exactly 0. The length property returns the one-dimensional span of a geometry. For a line, it is the distance from start to finish along the path. The bounds property provides the exact coordinate limits of your shape. It returns a 4-number tuple representing the minimum x, minimum y, maximum x, and maximum y. This is your bounding box. Consider a scenario where you have two GPS tracks from runners, both represented as line strings. You read the length property to see the total distance each person ran. You read the bounds property to define the exact rectangular viewport needed to display both of their routes on a screen. The math gets heavier when you need to measure the space between those two tracks. The standard distance measurement returns the absolute shortest gap between two geometries. It scans track A, scans track B, and finds the single closest pair of points. If the two runners crossed paths at an intersection halfway through their run, the scanned distance between their tracks is 0. Here is the key insight. People frequently confuse regular distance with Hausdorff distance. Regular distance finds the nearest points. Hausdorff distance finds the furthest distance between nearest points. Think of Hausdorff distance as measuring maximum drift. It represents the longest gap you would be forced to cross if someone placed you on the worst possible spot on one track and told you to walk to the nearest point on the other track. If our two runners started at the same place, split up by 2 miles in the middle of their workout, and finished at the same place, the regular distance is 0. The Hausdorff distance is 2 miles. It defines the worst-case separation across the entire length of the two geometries. There is one more measurement function called minimum clearance. This one does not compare two different objects. It measures the structural stability of a single geometry. Minimum clearance calculates the smallest distance any node can move before the geometry collapses into an invalid state, like a line overlapping itself. If your geometry has a tiny minimum clearance, the coordinates are squeezed tightly together. A slight rounding error during a database export could break the shape entirely. If you want to simplify the runner data to save file size, checking the minimum clearance tells you exactly how far you can shift the points before the geometry ruins itself. Knowing how close two shapes get handles the basic collisions. Knowing the absolute maximum limit of their separation dictates how well you truly understand the spatial relationship between them. Thanks for spending a few minutes with me. Until next time, take it easy.